Hello again. In this video, we're going to talk about translating the graphs of absolute value functions. Remember, absolute value looks like a V. We're going to talk about translating. So first we need to figure out what translating means. In words that you may have heard before, this is a slide. Oops. All right. This is a slide. Which direction? Well, we can go left, up, right, down. The four directions. Maybe you want to go diagonal. It's actually a combination of left and down, or left and up, or right and up, or right and down. Okay, so let's talk about how to do that. And we're going to fill out this chart here, but I think first we should go to Desmos and figure out what x minus thrown in number here does to the graph and what adding a k. And keep in mind where these h's and k's are. Remember, these are just numbers. H is inside of the absolute value, and k is outside of the absolute value. That's very important because they do two different things, okay? So Desmos has this handy feature where you can add these things called sliders. So I did for h and k. All you do is type in the letters h and k, and Desmos will say add slider, and you say yes. Because then I can change the values for h and k and figure out what happens. And this is like the Desmos activity that's on the next page of this Canvas site. So if you wanted to pause here and go do the Desmos activity, that's kind of an intro exploratory activity, that might be helpful. Anyways, so let's do h first. What happens when we have h as a positive number, but really it's negative because it's minus here, so keep that in mind. So what happens here? Which way does it go when h is positive, when it's x minus something? It goes to the right, which might be counterintuitive. And that just has to do with rearranging things once you go out of the slope form, which we can talk about if you have questions about that, about why it's like that. So then back to 0, what happens when h ends up being negative, which means that we're doing x plus a number? We go to the left, and it's just a slide. So these are all slides. So x minus h, what does this do? I'm just going to go ahead and type. What does the constant do? It moves the graph to the right. And then when h was a negative number, which made this x plus h, it moved the graph to the left. Okay. And maybe I'll do some math here just to make sure we're all on the same page. Maybe my pen will work. So right now, h is negative 6.4, and I just want to make sure we're on the same page of why that ends up being like x plus 6.4. So if this is the absolute value of x minus h, which is negative 6.4, it's a negative sign, and the absolute value. Remember that it's like subtracting a negative, which, you're subtracting, so you're facing backwards, and then you're a negative, so you turn around, so then you end up stepping forward. So it's, or you may have heard just like two negatives make a positive. So it ends up being x plus 6.4, so we end up with x plus 6.4. So this is why a negative h value ends up being x plus the number. Okay, I hope that makes sense. Now let's do k. So let's just go ahead and start moving this guy around. What happens if k is a positive number? And this, we don't have to deal with this counterintuitive negative thing. So if k is positive, what happens? It goes up. What happens if k is negative? It goes down below the x-axis. So let's type that. So if k is positive, this absolute value of x plus k. Actually, maybe I need to be more specific than say moves. I apologize if you've already been writing this. Let's change this to slides, or maybe you can just throw this underneath as a side note in parentheses. We're talking about things sliding, which is important. Slides the graph up. And this one slides the graph down, if you remember. Okay. So let's keep going. Got a couple examples now. So we're going to graph each function and then compare it to this graph of the absolute value of x. And we're going to describe the domain and range. So you can always use Desmos as a tool to help you. I'm going to use the concepts that we just talked about in that table, so keep that open in front of you if you have it. Okay, so we're going to do absolute value of x plus 3. So first, I'm going to just draw this parent function, which starts at 0, 0, and then goes over 1, up 1, just with a slope of 1 up here, and then a slope of negative 1 over here. Okay, this is our parent function. So remember, this is f of x, so that's just the name of the function, equals the absolute value of x. Now I'm going to change colors. Let's do maybe, oh no, okay, we'll do that color. Let's do absolute value of x plus 3. So remember, what does this plus 3 do? We go up 3, move everything up 3. So I'm going to start with the vertex and go 1, 2, 3. So it means the vertex is going to be here. And then nothing else changes, so the slopes are still 1 and negative 1. So then we can go ahead and draw this. And then this one, slope of negative 1. There. And then this is g of x, this red one. All right. And now we have this function, m of x equals the absolute value of x minus 2. So this minus 2 is inside of the parentheses. So that means you know you're going to be going left or right. So now you need to determine if you're going left or right. All right, we got a minus 2, which means that h equals 2. So that means we're going to the right. 2. So for this one, I can draw the absolute the parent function as well, but I have it right here, so I'm not going to. But we're going to move this parent function to the right 2. So I'm going to start with this vertex, move it over 2. So 1, 2, move it over, and then slope is still 1. So we just go up here. Yep. And maybe I'll erase these lines that I made. That's how we changed. Can you do a combination of these? Absolutely. You can go left and then up. And then you'll have a different graph there. And that's that. That is how you shift absolute value functions in the coordinate plane. Keeping in mind that this is a very common concept in things like math art, or not even math art, but just regular art too. And it's really just the